Hello and welcome to the Production Roundtable. My name is Evan Clary. I'm with JS Machine, and joining me today are David McBeth and Nicholas Harvey from Apex International, and they're going to tell us a little bit about what they do. So thank you guys for joining me today.
Well, thanks very much, Evan. I really appreciate the opportunity. Hope that you were doing well in this crazy COVID crisis and keeping safe.
Yeah, doing my best. Nick, good to see you.
Yeah, good to see you. Thank you for letting me join from Manchester across the pond. So hopefully we can have some good dialogue. Just the benefit of yourself, I'm the technical director for Apex International.
Okay,
and that's
good.
the aim of where I'm coming from.
And your company is based out of the UK?
No. We're headquarters is in Holland, the Netherlands, and then we produce also in India, Brazil, US, and of course also in Italy. But the headquarters and the main frame is Holland.
Okay.
Go do whatever you were going to do.
All right. Well, very good. So we were kicking around some ideas of what we were going to talk about today. And David, I know you and I had talked about this, and we said, we were talking about high performance glue set manufacturing and what materials are they made from.
Yeah, sure. So, well, first of all, welcome to my my room. Again, it's a little bit crazy the way we're all working today, but like I said, Evan, a great opportunity to be able to give you a little bit more insight in let's say the glue metering technology and some of the advantages that we see in the marketplace and how those things can really react with customers. From a glue set manufacturing perspective, one of the things that we're very proud of is certainly the quality of the glue sets that we actually manufacture. And the reason that I say that is they're a very unique set in the marketplace, which is really made from a stainless steel glue roll. And we also have a ceramic metering roll, and obviously a little bit different than the technologies that are out there and available in the market today, which primarily has been a copper and chrome, let's say, glue roll and a chromed metering roll. So there's really big differences with the two technologies.
Well, from our side, we've done a lot of work. Been involved in this product for quite some time. We saw some pitfalls in the industry back 10 years ago, if around that period. One of those was lifespan of refurbished rolls, which we decided and made the decision to build everything back up with steel and stainless steel. So you tend to, when you're looking for longevity and lifespan of a replacement or refurbishment, then you want the same life as you got out of it when it was brand new. And we understand in our makeup and reference the stainless steel versus the chrome. Both perform in the industry. There's no question. The stainless steel has some advantages in so much that it doesn't chip off and it won't flake, and obviously it is corrosion resistant. And those are three very key points to glue sets and advantages in getting an even layer that's applicated.
Definitely.
I think
corrosion.
I think the thing, Evan, as well is I think as Nick pointed out at the beginning, as we're a global organization, we do offer, or there are sets that are out there that we actually do a combination of whether it's copper and chrome or whether it's hardened stainless steel. The decision that we did here was really to service the market more on the stainless steel sets, and there's key reasons to that, which Nick, from a technical point, will talk about.
Very good. So I wanted to ask you, what is TRTR tolerance and why is it important?
Well, again, this comes back to the construction of the rolls, which gives you the ability to get a tighter TIR. That's a total indicated run out. Basically, how round the roll is all the way across the full surface. The standard chrome and Dr. roll and glue roll has around about a 30 micron TIR across the face length. So when these two, you don't want them to contact and hit each other in production. You've got a bearing tolerance and you've got the TIR from the rolls. So there's a minimum gap that you can get to before it is too risky to cause damage to the roll. And when you change the construction and you go to the steel and stainless steel and then the ceramic Dr. roll, you can actually halve that. So you're down at 20 microns for the glue roll and around 10 microns for the Dr. roll. That means that effectively you can get closer and a smaller gap when you use the stainless steel and the ceramic. And a smaller gap means less application. Less application means less cost in your glue application and a more even transfer.
Yeah, more precise amounts of glue that are going to be applied too, I guess.
Yeah, I mean, there's a lot when you think about it. You know, what's the negatives of giving too much glue? And you know, one thing's for certain, it's going to stick. So you're not going to get any delamination. But on the flip side, you're going to get this ribbed effect on the board because when the glue dries, it will pull down on the sides of the flutes, and also the cost. You know, cost of the starch is a big one, and also the more moisture that you apply, the more drying capacity that is needed to dry the board out, so you don't get warping. So it is a key factor.
Sure. Well, that seems to make sense. Now, David, what's the advantage of hardened stainless steel to the chrome glue set?
I think, as Nick just pointed out there, you know, the major key benefits really is really the longevity of the roll. Definitely, you know, it's a harder surface. Having a harder surface, obviously, in terms of impact, if there is any impact, then it's not really going to damage the rolls. I also think as well, in terms of stainless steel, the actual transfer of the starch or glue within the roll as well, it seems to be a better release character within stainless steel rather than ceramic. So in terms of it releasing onto the material, the application is by far better, meaning that it releases better and it also stays cleaner a lot longer. I think one of the other key benefits as well is across that roll, you're not going to get uneven wear from side to side. And obviously, as you get uneven wear, what you tend to do is really open that gap a little bit more. That's going to apply more of the glue and starch to the material, and then you get the inherent problems like Nick just pointed out, where the board can be a little bit wetter, it can start showing the flutes a little bit more, and it needs more drying time. So it really comes down to that application of stainless steel that's on the roll.
Okay. Well, now that we know the difference in materials, what about the energy benefits to how glue is applied?
I think to touch on this, you know, all the glue sets that are in the industry apply glue. That's clear. I think the energy benefits only come on how much drying capacity and also what speed is needed to dry that board out. So it gets to the end and it's flat. It's not warped. It hasn't got the ribs. And I think, you know, it's not only about making a nice flat board. If you've got a flat board, that means it's going to run through your printer faster, and it's going to have less clogging issues on the printer. So downstream, it definitely gives you a better print quality on the surface. But I think the bigger impact on converters is the fact that the speed that you can run the board through the printer is is increased when the board is flat and as good as possible.
Sure. Yeah, it moves through the vacuum transfer sections well. It won't jam up. It's easier to print on. There's many advantages if you can get flat board without warp.
I think also, Evan, like the energy savings, as Nick said before, I think that, I think when people are really looking at this type of technology and what really is the best technology for their corrugator is, I think people really don't look at the energy impact of what these sets can actually make to them. And I think when people are just looking at roll technology, they think, okay, well, this roll is from a similar cost, and this is the way that it's going to perform. But overall, I think when people are choosing these types of technologies, they really need to evaluate the full impact of what it does, not only just upstream but downstream, and the overall cost of efficiency benefits that they can actually offer. So, if you're not using as much steam and you're not using as much drying power, then obviously from a power consumption, the cost savings are actually tremendous. So those really needed to be taken into equation when people are really looking at what is the best technology for their corrugator.
Yeah, I agree. It's important to look at things from a total cost perspective because it's not just a one-time thing. It's not just a one-day thing. This is day after day, month after month, year after year that this will be saving energy.
Yeah.
Yeah, and if you look at the value on that aspect, it is if you've got a glue set that saves you 5% on starch and 10% on energy, for example, then you've got a free glue set. Yeah, it's pays for itself time and time again. Yeah.
Very good. I guess shifting gears a little bit, compared to conventional types of analogs, tell me about the GTT analogs and what's different about it and how it's manufactured.
Okay, well, GTT came around. It's around about 10 years old now, so it's not what you would say a new technology. We got a strong patent that's been used for the second time, so it's been renewed. Really, it's to put it into essence, it's a continuous burn laser as opposed to a woodpecker pulsing laser. So anything that you've got a constant energy and a constant power that is creating the engraving has to be more consistent than a pulsed woodpecker hitting the surface. So fundamentally, it's very, very different. When it first came out, it had a lot of success, a lot of interest, and but we didn't stay still with that. The GTT had some issues. I'll be transparent. I'm not the sales guy. I'm the technical guy, so I get shot afterwards. But that's another story. But no, in the end, we've learned and we moved it along. It's developed, and a little bit like a winding river. If you change it out of printing like a winding river, you tend to get in the curves of the river. You will get the silt and the buildup on the edges. And in essence, that was what was happening with the original first time around GTT. You would get some ink clogging in these. That was recognised, that was understood, and we worked hard to develop an angle and a pattern that basically doesn't allow that to happen. So the cleanability of the roll is now very much better. It transfers in a very, very different way. There is less cell wall. Obviously, it's an open structure compared to a hexagon. But there's a lot of information and bits on the internet that you can look at. But in essence, when you've got anything that is rotating and you've got a liquid, that liquid will be forced backwards. That's just the nature of physics. And when it's forced backwards, it hits the back cell wall and then it lifts. So if you can imagine the surface of an analog, there's these tiny lifts and ripples of ink. And why is that important? And to explain is that I'm a firm believer that a print dot on a plate will never ever dip inside an analog cell. And I can say that with quite vigor, because you've got a soft polymer printing plate. It's mounted on a soft, even softer mattress of a tape in a lot of occasions, and it's got another dot right next to it, and next to it, and next to it. The amount of pressure that you would have to apply to get one dot to jump, or all the other dots to be squeezed down, and that one dot to stay up in rotation at speed, it's impossible. What does happen is it dips into that little bubble that's on the surface because it's hit the back wall and it's lifted. So when the surface in rotation of the analogs has these tiny, tiny little bubbles on top, your dot will dip and can dip into that, fully accepted, but not inside the analog cell. And what you get with GTT from its design is that there is no back wall. So you don't get that lift and that raised area. You've got a very calm, very stable ink that's been transferred to the plate. So fundamentally, very, very different. Yeah.
Well, I think as well, Evan. Like, you know, the technologies that are, let's say, used more frequently within the marketplace today has always been a six-sided cell, and the six-sided cell, whether it's a conventional 60-degree hexagonal cell or whether it's a 75-degree long elongated type cell, they're still surrounded by walls. Yeah. So what happens is, as Nick said there, you still get that backlift no matter if it's a long cell or a conventional cell. So in effect, what that does onto the corrugated board is not transfer evenly onto the solid board. So what you can actually see is more increased washboarding on the board. And the other thing is you'll get more, let's say, pinholing down onto the material. And more often than not, if corrugated printers are trying to put down a solid print and they're not getting the lay down, usually what they'll try and do is try to skip feed the board twice or have a double pass on the machine to get that density down onto the board. I think more with the open slalom type river technology, it applies that ink a lot more consistently because there's no trappings around walls that then allows that ink to free flow onto, like, whether it's a recital board or a heavy liner, and it's got saturation in there, you're still going to get a good solid down in one pass as that actually goes down.
Let me ask you, from your experience, you were talking about skip feeding the board to allow time. What about adding a dwell in dryers? Is that going to make a difference in this situation?
I think definitely dryers, depending on what you're trying to print down, especially when you're trying to do combination work. We've seen that's been key. So certainly, yes, dryers and a well will definitely give added benefits. But, you know, there's still a lot of older machinery that's out in the marketplace today. You know, one of the markets that we service is Mexico, where there's a lot of new technology, but there's also a lot of older technology that's down there as well. And the board type that they use down there seems to be a lot rougher than what we would have, let's say, in the United States and Canada. So a heavier application of ink and more free flowing type of technology seems to help, certainly on that rougher recital board, and with, let's say, a lot of the older type presses that's still in the marketplace today.
I think it's important, just while we're talking on the GTT, and you might have guessed this is my area of speciality, but it isn't just an open structure. There was a lot of work done with many different versions of open structure that failed in testing, and again, it's very, very different. I think when we look at corrugated, an area that's not really explored or developed until now, but hopefully will be, is that the GTT will never allow air to enter the doctor blade chamber because it's an open structure. No air will enter. And what you have with any form of cell-based structure is the speed of the rotation. Once your cell has delivered the ink to the plate, it then has it's never got nothing in it. It's got ink or air. So it fills with air, it comes back round. That air does not want to enter into the doctor blade chamber because it's a positive pressure. But because it's trapped at the speed that it's going at, it gets dragged in. And then inside the chamber, you have this kind of washing machine effect where you've got all these tiny little bubbles. And with water-based ink especially, a lot of printers and converters have to put some additions of antifoam into the ink to stop the ink moosing. Some of that can be down to the pump. If they haven't got if they've got a very rough way of the pump working, but a lot of that aeration is down to the analogs. And what you find with GTT is you have to put no additional antifoam in, which has it's a benefit not to be able to put it in because it's a manual addition, and GTT allows you to not need the antifoam.
Well, in today's world of quick setups, small orders, anytime you can avoid adding something or increasing the number of steps for a setup, it's always a good thing.
Yeah. Yeah, it's a key factor. To be honest, you have to, from an ink manufacturer's aspect, you have to put an element of antifoam in to actually produce the ink. So that's key. But also they will also add a little bit extra and also give this opportunity of the manual addition to the printer. And nobody likes to throw away waste and throw away ink. So how much antifoam has been put in to an ink that's been to press and then comes back and then goes back to press, and an operator by default thinks, you know what, I'm going to put some antifoam in, and before you know it, the levels are out of control. So if you can eliminate that, it's got some key benefits for the printer.
Sure.
I think as well, Evan. I mean, one of the things that we've certainly found from our customers is they've been able to use, let's say, a lower type of viscosity. So instead of running, let's say, at 22 to 25 seconds, for example, they've been able to reduce that down to maybe 17 or 18 seconds, which obviously for them has been a major benefit because they're not using as much pigment. So with it being free flowing, it does give you those advantages as well. And that's what we've seen with our customers.
Well, that's certainly good. That's very interesting. What's the range of LPI for the GTT analogs that's available?
I think like I said before, it's kind of a unique product, and you can't really give it like for like comparisons because it's not about the size of the opening. It's about the how smooth the laydown is. So typically, it's quite a difficult sales message, if I'm honest, because what the GTT does is give you a bigger range. It doesn't give you a range of colors, okay, or densities or strengths. If you've got a 8-volume equivalent, an 8-volume GTT, it is only going to give you that 8-volume ink color strength. But what it will do, it will give you the detail and the sharpness of an analog that is maybe 6-volume. So that's the key benefit. The color strength is fixed to the GTT profile. If that's an S or a M, an L, whatever the profile is, there is a volume associated with that, which we advise the customers of. But what it does is it gives you a far better detail in the print. So put it into old money. If it was, for example, if you had a 500 lines per inch with a volume of 5, just random numbers, and you took the GTT with a volume of 5, you would get a similar color, but your printing detail would be better. So it would be like a 700 lines analogs. So color strength. I'm elaborating on that because we've fell into the thing in the past where people said, "How can an analog give me two different colors?" Well, no, it can't. It gives you that color. It just gives you the benefit of being able to print finer detail.
I think as well, Evan, like one of the things that we found here again, going back to our customers, and we do have a large corrugated GTT install base here, and the benefits that the customers have definitely found is you're really using two specifications of analog. So when Nick's talking about small and large, the way that we brand these is a little bit like a shirt size. So when we talk about shirt sizes, we talk extra large, large, medium, and small. The average customer that would be using for example, a 65 line printing plate here, certainly in the North American market, would be using something like an XL type roll. Okay, and that XL type roll, for example, could be a 9.5 BCM, for example. But it would allow you to print solids down, but also allow you to get to a screen rule in about 65 lines per inch on a printing plate. If you go to the other shirt size being an L, it may be that, for example, that would give you something like let's say 7.5 BCM, but it would allow you to print screen plates of up to 85 lines per inch with a good solid that's laid down. That in general has been the specifications that have been going into the North American marketplace. Usually anything that's a little bit mediums and smalls and extra smalls, then you're talking more on the higher graphic machines, where they'd be looking at printing plates of around about 100 to 120 lines that would be on that printing plate. So generally for brown boxes, which probably is around about 60 to 70% of the work, in terms of where we are today within 2 or 3 color type work, it would be anything between a large and an extra large that gives you that punch on the solid, and it also gives you the clarity down on the lines per inch on the printing plate. That's really where the true value is of this technology.
Let me ask you this: if someone were to purchase a GTT Analogs and then eventually need it resurfaced, do you offer that service as well?
Absolutely.
Yeah, absolutely.
We can even convert conventional rolls to GTT today. So if customers are running a long cell or a traditional 60-degree cell, in terms of apex manufacturing, and it's something that we're very proud of, and our key customers are aware of, is we're the only Analogs manufacturer today that can offer every type of engraving. The GTT is a patented engraving, so we can take any roll back, whether it's an apex roll or somebody else's roll that's a conventional type 6-sided roll, and convert that to a GTT roll with no problem.
I think just one other thing just to touch on, and again, because like I said, it's quite a hard message to get across. But maybe it's easier if I explain the process that happens across in Europe. Is that people will say, the sales guy will come back with a request from the customer that I have a 400 lines per inch with a volume of 8. What's the GTT? Then I go back to the sales guy and I say, okay, right, does he want more color and the same detail? Or does he want the same color and better detail? Or does he want a little bit of both? Because we can pick, and this is the power of the GTT. There could be 3 GTT profiles that would fit into that box, and either give him more color, less color, more detail, less detail, or somewhere in the middle. So, but that's where we get this benefit from having a bigger range. And when you come back to refurbishing and repeating, just through logic and facts, there's 50% less wall. Okay, so therefore, on the wear of an Analogs, it's going to have less of an effect. because there's less wool to wear away. And secondly, it's far more consistent to repeat, and we've got that same fixed profile. If you take an M, for example, a GTT M, it's a GTT M all the time, every time, never changes. If you buy a 400 lines per inch conventional cell, sometimes it's 5 volumes, sometimes it's 4.5, sometimes it's 6.5. There are so many different variations with the conventionals that it's very, very difficult to pinpoint. Bang! This is the standard. And when you've got GTTM, we don't do one of these a month. We do 1,000 possibly. It's or 500 across all the plants, and it's the same engraving of the same design of the same profile.
I think the key thing, again, linked to what Nick's saying there, Evan, is again, some of our customers here, when you're talking about the big corporate brand type colours that go down onto the boxes, you could be talking an orange, you could be talking a green, you could be talking a red. The key thing with what we found with our customers with this type of technology is because the standardization is so dialed in and more consistent than a six-sided cell, what it's allowed them to do is to be able to print at multi-site locations, whether that's East Coast, West Coast, North, South, especially within the national accounts that's printing thousands and thousands of boxes up to a color standard. What the technology's allowed them to do is really print that at any of their facilities, and it guarantees them for that brand color within a delta E value that's qualified that it does 100% match. So it's consolidated their Analox technology down, but it's also standardized what they've got within the machines, allowing the corporate branded colors to be printed at any of their locations, even if they had a disaster scenario and one of the presses that went down, and this can happen, and they desperately need an Analox roll. If they having that same type of technology allows them to switch between one machine and another and ensure that the consistency is 100% correct. Because as Nick said there, if you've got a 360 line roll and there's a plus or minus tolerance, or there's some wear characteristics of that roll, that orange color or that green color or that red color could be completely different from one box to another. So it's key.
From that perspective, I can certainly see the importance. That's an interesting way to put it.
I think one thing, just again, not the sales guy. When this was developed, and let's look at the essence of this, is that potentially this will reduce the number of Analox rolls you need in your inventory, which is less capital cost. It's more standardization, and it's more consistency. I can tell you that was a very interesting discussion when we had this brainwave and we put it to the board and say, hey, we've developed something that means we can sell less. They weren't overly impressed, let's put it that way. But in the end, it's they saw the bigger picture.
Yeah.
And the industry as it is now, there is there are processes out there that's absolutely fixate on GTT because it brings them the consistency that they didn't have in the past.
Well, very good. I want to thank you guys for taking the time to join me today. I know we've been going back and forth on our schedule trying to eventually get together, but I'm glad we were able to make it happen today. And I'm sorry for any background noise. I'm in a customer's facility today. I'm up in Folk Packaging in Biddeford, Maine, installing a machine right now. So I apologize for that.
No problem, Evan. Thanks for the opportunity. Hopefully, all our customers get some value out of this, and if we can be of any help to you or customers out there, then feel free to reach out to us. You can probably see that I've got my suitcase packed behind me, so I'm ready to go at any notification.
Well, very good. I think we're all going to be traveling a lot more very soon. I think you said you have been busy traveling already.
Yeah, we still got customers that we are actively supporting. So yeah, I mean, I personally I've been on the road a little more than I would like to, but you know, it's part of the job, and you know, we'll get out there and support the customers wherever we can.
Well, very good. Nick, I hope the salespeople don't shoot you, like you mentioned.
Me too. In fact, I'm quite glad I'm home office based right now, so the risk is far less. Yeah.
He brings us all down to the ground, Evan. He stabilizes us. That's all I can say.
Well, very good. Like I said, thank you so much for joining me, and I'll post the video up on YouTube, and I'll send you the links as well.
All right, buddy. Thank you very much, Evan.
Nice to meet you. Bye. Bye.
Bye-bye.
Bye, guys.